Here we go.
Here, in my opinion, is the easiest way to remember the chain rule. Because you've been using it, there's nothing really new to memorize. Watch. If you were taking the derivative of the sine of, say, x cubed, just raise your hand if you know what I should write. Hands up. Hey, everybody. What do I write here? Let's go, Justin.
Cosine x cubed dx cubed over.
How many knew that? 22 for Justin. Watch. Here's the chain rule as listed on the green sheet. Okay, there's the chain rule as listed on the green sheet. All we're doing is we're basically thinking of the sine function as being our f. So the f we're using would be f of x equals the sine of x. And then the g function that's getting plugged into our f function. So here's f. Here's the g that plugs into f. That's x cubed. Do you need me to give more explanation there? Oh, please.
How would you know that it's not the product rule?
Oh, good comment. 2 points. So if you're using the sine function, cosine, any of the trig functions, natural log, square root, probably not square root so much. It's never multiplied. It's always sine of, cosine of, natural log of. So those don't ever mean multiplied.
Okay.
They're always saying these special functions with some input. Can I answer your question?
Yeah.
Sure. So yeah, I can't use the product rule here because these two are not multiplied.
So all of those would use the chain rule?
So for you, you just use the sine rule, the cosine rule, the ln rule, which have the chain rule built in. That's what you did here. So you were using the chain rule.
So is the chain rule only applicable to like those?
No, so the chain rule works anytime you have any function whose input is some other function. Okay? And really, you don't have to worry too much about this rule by itself, because again, the way you learned the rules, you're already using them. And I really believe strongly it's a better way to learn. Had a student from last year come visit me. She's taking Calc 2 at UVU now. And she made a comment that one of the students came to the board to do a problem, and he started using the chain rule and the other rules, and she's like, man, that is confusing. The way she learned to do it, just way faster. So anyway, we're good to hear. Okay, cool. So my f function is sine, and then g is just x cubed. So that matches up with this. So notice, equal means these are the same. So all we did was take the derivative of f. But since f was the sine function, the derivative of the sine is the cosine. You plug into that derivative the g function. So we're plugging in the g. So here's the f prime part. Here's g being plugged in. That's this right here. And then you multiply by derivative of g, or d dx of the g function. So you already know how to use the chain rule. You've been using it. It's very natural for you. Questions? Okay, cool. Can I erase this? Awesome. Okay, up here, they give us this clue. I don't really know why yet, so I just keep reading. I don't really know why I have this clue either, so I keep reading. Now I know that they want me to do this. So they want me to find a derivative, d dx, of f of x cubed. Like that. Okay? Questions? Ashley, please.
Is it asking for the second derivative?
It actually wants the second. It's perfect. So I just know I have to do the first and then the second. 2 points.
So do we don't want the derivative things? Just make it into that function.
Say again, Justin.
Like, do we know we have to do the derivative because of that formulas having?
Yeah, this symbol means second derivative. Yeah, no, we're just reviewing from unit 1. 2 points.
So you just find the first derivative of the y prime and then do it again.
Then just do it again. 2 points. Are we good? Okay, so here's where I have to use the chain rule. So just like before, you said the derivative of sine is cosine. Well, the derivative of f is just going to be symbolically represented as f prime. And you plug in the g, which is x cubed in this case. And then you finish by taking d dx of the x cubed. That's all you have to do to use the chain rule by itself. It's really not complicated. Question? You need to do anything again? Awesome. Okay, so let's see. So we'd really have, that would become 3x squared multiplied by f prime of x cubed. Perfect. Okay, now I need to do it again. So let's see, we have d over dx of this thing. So raise your hand, please. Always learn much better if you're thinking with me. What rule will I use first here? For hands? What rule gets used? I'll pay everybody. What rule gets used first? Just don't take payment if you're not raising your hand. That's how I kind of judge how well you're following. So let's go, Sarah.
Is it the product rule?
So I have one function multiplied by another. So I take the second, which is f prime. I forget my equal sign. F prime of x cubed. That gets multiplied by d dx of 3x squared. And let's see, minus, no, plus, sorry, 3x squared. And then d dx of f prime of x cubed. You need to talk more, please.
But do you need an equal sign in from the blue step?
Right here?
Yeah.
Really good question. 3 points for that. Take 4. I'll pay everyone else some points if you can tell me. Do I want an equal here, yes or no? And why or why not? Just hands, please. Do I want an equal sign here? Yes, no, why not? Let's go, Kylie.
Is it no because you're like starting at the conclusion?
Perfect. Yeah, I don't want to put equal here. I would be declaring that this is the same as this, which it isn't. Like I found the first derivative, so I want this to equal this. But now I'm doing something new. So I'm going to find another derivative, so these two aren't the same. Putting an equal here would declare these to be the same, so I don't want that.
Okay.
It's a really good question. Who knew that? 2 more, please.
What if you put like y double prime equals that? Like you declare that this.
2 points for that. I really don't want to do that either, because nowhere in the problem have they declared y to equal anything.
Okay.
So I don't want to. So I just start fresh. So please.
So that 3x squared f times the one above, is that like the first derivative? And now we're finding the second.
Perfect.
Okay.
It's perfect. 2 points. Hey, awesome questions. Just keep doing it. And hey, I really do appreciate your high level of concentration and then just really quiet. I'm having some kind of trouble with my heart. It like skips beats. Like it's been doing it for about 1.5 years. It kind of got better. Like I had surgery and then it got better. And anyway, so I can't talk really loud. It like hurts. So thank you. I really appreciate it. Everybody good? I promise I'm all right. I always tell everybody, like, if I pass out, just, call for help before you leave. So, okay. Make sure somebody's coming. I've never passed out or anything, but I can feel it in my chest. Like, I can feel like, wait a minute, something went wrong. Like, there's pressure, and so it makes it hard to speak loud. So, I should say louder. Hopefully this is loud enough. So, are we good? Kylie, can you hear in the background? Yeah. Okay, good. We good to hear? Awesome. So now we say equals. Let's see. This would just be 5. This is going to be 6x. Okay. Now we just have to use the chain rule again. Because just like we had the sine of x cubed, we now have f prime of x cubed. Well, the derivative of sine was cosine. The derivative of f prime is symbolically f double prime. You plug in the g, and then you multiply by the derivative of that g. Question? Please.
Can we just go over that one more time?
To me, it helps to put up that sine example with the phone. All right, this is great. Yes. Okay. Kyle, you can summon the Galahads in the comments. We're making a video of this one, so you asked the question, right?
Yeah.
Let's answer the question first.
Sounds good.
So we had like d dx of the sine of x cubed. And the way we do it is we say the derivative of sine is cosine. Then you plug this in. And then you take d dx of the x cubed. Like that. So the same thing is happening here. You got x cubed, you've got a function, f prime, you had a function sine. The only difference is, instead of the derivative of sine being cosine, the derivative of f prime is f double prime. You see it? Yeah. Good work. 2 points. Anyone else? Awesome. Okay, next line is going to say, questions? Keep going. Okay, there's no more derivatives to be found, but none of the answers look like what I've written. So somehow these 2 clues have to be used to get one of their answers. So the first thing I notice is, like, actually paper for the whole room. Hands up. Not looking at little details, but just kind of the big picture. What's most significantly different about my answer versus any of these answers? Hands. Like, what kind of jumps out at you first? Looking for the big thing. What's going to jump out at you and say, wait a minute, I got to fix that? Kennedy?
The equations in the answers have a g of x and aren't supposed to.
Good eye. No g of x here, so I got to somehow get a g into this thing. How many saw that? Point 2 for Kennedy. Other thing, anything else big that you noticed? Let's go, Abby.
There's also no f double prime.
Yeah, not even an f single prime.
Yeah.
Like, I noticed that no primes here, so I got to get rid of these primes. How many saw that? Point 2 for Abby. So what I noticed is this right here. This says the derivative of f is equal to g. That means f prime of x is the same thing as g of x. Pretty good there. Which means this f prime here, so I've got, so let's see. Yeah. So I have 6x, so f prime of x cubed is going to be the same thing as g of x cubed. Question? Please.
So what is like f of x, so like equals g of x, and then on our question we have the like x cubed, would you just bring whatever exponent it was with it?
So what this means is f prime of something is the same thing as g of that same something.
Okay.
So in our case, the something that replaces the x is x cubed. So the x gets replaced there as well.
Could be anything.
Could be anything. You could have said f prime of 5 is therefore the same thing as g of 5.
Okay.
Yeah. Good question. What else? Cool. So plus, these factors are all multiplying, so I can multiply them together. So I get 9x to the 4th. Question there. Okay, f double prime. What says here, okay, I'm going to copy this page over so I can do some more writing. Just give me a second. Okay, so this over here. That doesn't work. That's better. And then I'm trying to figure out what f double prime of x cubed is. So I know that up here. So I know that f prime of x is the same as g. So if I take the derivative of both sides of this, I get f double prime of x, same thing as g prime of x. Questions to there. So here I can write 6x g of x cubed plus 9x to the 4th g prime of x cubed. Questions there? Well, up here it says that g prime of x, same thing as f of x squared. Which means g prime of some number is the same thing as f of that same value squared. So I use that here. So now we have 6x. Well, that's a bad color. Guess that's all right. So we have 6x. Why is that so light? Never mind, talking to myself. So I have 6x. Frustration is setting in. That's super big. Good grief. Man alive, stupid machine. There we go. So 6x, g of x to the third, plus 9x to the fourth, g, nope, this one here, right? F, thank you. F of x cubed being squared. This is why I've been telling you, whenever you take away an x, make sure you put a set of parentheses in place of the x. It prevents errors. Question? So then this becomes 6x g of x cubed plus 9x to the fourth f of x to the sixth. Question? Cool. Okay, go to problem number 13.